Hello, college algebra. I was just bored sitting around here in my classroom waiting for the football game to start so I could listen to my daughter sing the national anthem, and I thought I'd make some notes for you guys so you could learn this weekend about another wonderful college algebra concept called solving radical equations. I think this is super fun. So let's go ahead and get started. So equations involving radicals. So basically what we're doing, instead of square rooting to solve, we're going to start squaring to solve because we're starting with square roots instead of starting with x squareds. So as you can see, the directions say to solve each of the following. Check your answers to make sure they make the original equation true. You have to check your answers. Unlike other areas in algebra, one of the solutions could, or one or more of the solutions could end up being extraneous, meaning I got this answer, I did all my math right, but when I plug it back in, it really doesn't equal out. So you should always check equations when working with square root equations, or check your answers. So the goal for solving square root equations is that you need to get the square root by itself. So you can see this minus x. It's on the same side as the square root. So the first thing I'm going to do is I'm going to add x to both sides. That's going to look like this. The square root of 6x plus 7 equals 2 plus x. Now logically, the next thing I'm going to do is I'm going to square both sides to get rid of that square root, because that's really our goal. We need to be able to get this x out of that square root, so if we square it on both sides, that x is going to be gone. What happens here is the square and the square root cancel. And over here, it's not just 4 plus x squared. I can't do that. I actually have to FOIL out 2 plus x times 2 plus x. That gives me 6x plus 7 equals 4 first. Outer is 2x, inner is 2x, and last is x squared. Now, this is looking an awful lot like something we've done before called solving quadratics, which is actually what we're going to do now. We are going to get this in quadratic form, and we're going to solve it for that. So solving this, I get negative 3 minus 2x plus x squared, or I'm going to rewrite that as x squared minus 2x minus 3 equals 0. That looks familiar. It is a quadratic. We can either use factoring, quadratic formula, or completing the square. The square root method won't work with this because I have more than one x. I'm going to factor this. Two numbers that multiply to be negative 3 and add to be negative 2. Are x minus 3 times x plus 1 equals 0. When I solve those, I get 3 and negative 1. I certainly need to check this. So I'm going to plug 3 in for x. Miss Lewis is using my Keurig right now, so if it's noisy, deal with it. So 6 times 3 plus 7 is square root of 18 plus 7. Got that minus 3 equals 2. Square root of 25 minus 3 equals 2. 5 minus 3 equals 2. 2 equals 2. Looks like 3 is a solution. So I'm going to erase that, and I'm going to check negative 1. So now I'm going to plug negative 1 in for all my x's there. So negative 6 plus 7 plus 1 equals 2. Square root of negative 6 plus 7 is 1. Plus 1 equals 2. Square root of 1 is 1. 1 plus 1 is 2. Certainly 2 equals 2. Therefore, these are both solutions. Normally here to ask if there's any questions, but obviously that's not going to work. Let's go on to the next example. Okay, so I was looking at this problem here. I have a problem because I have 2 square roots, so we got to deal with 2 square roots and figure out how to work that. So what we're going to do is basically we're going to isolate one of the square roots, simplify it out the best we can, then we're going to isolate the other square root. So to do that, I'm going to add the square root of x plus 4 to both sides. So the next line is going to look like this. 3x, the square root of 3x plus 1 equals 1 plus the square root of x plus 4. Now I'm going to square both sides. That gives me 3x plus 1 equals, ooh, I got a FOIL again. This looks really weird though, because now I have the square root and we got to FOIL the square root. So here's how we're going to do it. These are my firsts, these are my outers, these are my inners, and these are my lasts. Okay, so I'm going to leave it 3x plus 1 over here equals 1 times 1 is 1. Outer is 1 times the square root of x plus 4. So I don't usually write that 1 in the front, so I'm not going to do that. Now I'm going to take the square root of x plus 4 times 1. And I'm going to do my lasts. So when I multiply the square root of x plus 4 times the square root of x plus 4, that's kind of like saying the square root of x plus 4 squared. And we know that the square root and the square cancel because we did that over here. So that's just going to equal plus x plus 4. 3x plus 1 equals, I'm going to combine my like terms on this side. So 1 and 4 make 5. Plus the square root of x plus the square root of x is 2. I'm sorry, the square root of x plus 4 plus the square root of x plus 4 is 2 square roots of x plus 4. And then I've got this lonely little x over here. I'm just going to write it x. Now I'm going to move the x and the 5 to the other side. So my goal I'm trying to accomplish here is to isolate the square root. So I get 2x minus 4 equals 2 times the square root of x plus 4. Sometimes I get really lucky and this thing over here that's not under the square root is divisible by this number. In this case, I am lucky. So I'm going to divide by 2 on both sides. I get x minus 2 equals the square root of x plus 4. If I'm not lucky, and it happens sometimes, I will show you how to deal with that at the beginning of class tomorrow, or Tuesday, or whatever the next day we meet is. I'm going to square both sides. That leaves me with x, ooh, I got x minus 2 squared. I got to FOIL it again. I like foiling. Foiling is fun. But on the right side, the square and the square root cancel, so I'm left with x plus 4. X times x is x squared, minus 2x for my outer, minus 2x for my inner, plus 4 for my last, equals x plus 4. Okay. X squared minus 4x plus 4 equals x plus 4. I'm going to get this x over here by subtracting it and that 4. So I should have a 0 over here. We're in quadratic mode now. X squared minus 5x equals 0. Gosh, I think we have a GCF of x. X times x minus 5 equals 0. X equals 0. X minus 5 equals 0. So I get 0, 5. And, oh wait, I shouldn't have circled that because they may not make the equation true. So we must check. Okay, I'm going to check right around in here. I'm going to plug 0 in for x, so 3 times, remember I'm going back to the original equation. The square root of 3 times 0 is 0, plus 1 is 1, so square root of 1 minus 0 plus 4 is 4, the square root of 4 equals 1. 1 minus 2 equals 1. Negative 1 doesn't equal 1. So we're going to exclude 0. It is an extraneous solution from my answer. Now we got to check 5. So if it just so happens that all of your answers are extraneous, then you have a no solution equation. I don't think that happens in this case. I think the 5 will work, but we're going to check it anyway. 3 times 5 plus 1 minus the square root of 5 plus 4 equals 1. The square root of 15 plus 1, oh, that's a perfect square. That's nice. That's 9. Square root of 16 minus the square root of 9 is 1. 4 minus 3 is 1. Well, that is as true can be. So the only solution I have is x equals 5, because that's the only one that made the equation true. One more example. Hold on to your hats. Ooh, we got a square root inside of a square root. That looks really scary, but it's really not too bad. So what you may see is this whole thing, this whole side here, is under one square root. And what's nice about that is I don't have to move anything to the other side. I can just start by squaring both sides, which is what I'm going to do. Square that and square that. And so the square root squared here is going to cancel, and I'm left with 1 plus 4 square roots of x. Ooh, that was a funky looking x. Let's try again, because that looks like a 4 and not an x. Oops. Okay. Oh, that's much better. And then I'm going to FOIL this side. So it leaves me with 1 plus 4 square roots of x equals 1 plus, I'm foiling, 1 plus the square root of x plus the square root of x plus x. Okay. Oh, look, I got to get this square root by itself. Oh, wait, there's one over there. Maybe I should combine them. Let's subtract 2 square roots of x. 1 plus 2 square roots of x equals 1 plus x. Oh, I think I want to get rid of this one and get this square root. Remember, I'm trying to get the square roots by themselves so I can square both sides. Uh-oh. I don't have a nice division here. If I divide both sides by 2, what's going to happen is I'm going to have a fraction on the right side with x over 2. So I'm not going to divide. What I'm going to do is I'm going to square both sides as it is. When I square this left side here, I basically am going to get the 2 is going to be squared times the square root of x is going to be squared. Equals, oh, I forgot to put my squared there, equals x squared. So if I square 2, I get 4 times x, the square root of x squared is just x, equals x squared. Now I'm going to subtract 4x on both sides. That leaves me with x squared minus 4x equals 0. Oh wait, I know how to do this. This is a quadratic, and I can take out a GCF. X times x minus 4 equals 0. So if I said equal those, each of those equal to 0, I get 0, and if I add 4 to both sides, I get 4. Gotta check them. So let's check my answers, 0 and 4. So 1 plus 4 square roots of 0 equals 1 plus the square root of 0. Well, that's the square root of 1 equals 1, which certainly it equals 1. So 0 gets a gold star. Okay, let's plug in 4 now. 1 plus 4 times the square root of 4 equals 1 plus the square root of 4. 1 plus square root of 1 plus 4 times the square root of 4. Well, that's the square root of 2. Square root of 2 times 4 is 8. Equals 1 plus 2. Well, 8 plus 1 is 9, and the square root of 9 is 3, and 1 plus 2 equals 3. So these both get gold stars. They are both a solution. And this concludes the notes for college algebra over solving radical equations. And I have a bad joke of the day for you guys. I have not done these much this year, but I'm going to start, and if I get too many complaints, I may stop, but they're cheesy and they're called bad jokes of the day for a reason. What is green and has wheels? Grass. I was kidding about the wheels. You guys have a great whatever time of the day it is for you. This is Mrs. Lauer signing off. Have a wonderful whatever.